HSRP has the ability to track the status of an interface. It's built right into the HSRP protocol. However, VRRP does not have this native tracking ability built into it. However, with object tracking, you can still accomplish interface tracking for VRRP. You can also track routes, IPSLA instances, or various lists of objects. So you do have the ability to track interfaces or track other objects with VRRP, so that way they're upstream links from your routers that are acting as the default gateways in that VRRP group have the ability to transition or fail over from master to backup and backup to master if those uplinks fail. Because right now, without implementing object tracking for VRRP, the only way this backup router will end up becoming the master is if the hello ceases to exist between these two routers across this layer 2 network. So if this link goes down, great. The hello packet's missing. Our backup router becomes the master. The router goes away. The hello packet goes missing. Our backup router becomes the master. But if all of a sudden this link fails, nope, the hello packet's still going back and forth. So therefore, this is still the master. And since this is the master, traffic now gets dropped. What about the link further on down the path? For example, if it wasn't a direct failure to this specific interface, what if it was further along? Let's say this wasn't a point-to-point link. Let's say there was multiple devices in between. Well, then through the use of object tracking with IPSLA, then you can track objects that are further away than this interface. So, but because there is no integrated interface tracking for VRRP, you have to use object tracking to accomplish the goal. So with object tracking in this case, you will create an object that analyzes the status of the interface. So this object we're calling 1, and we are analyzing interface Ethernet 0/0. And what are we analyzing about it? The status of the interface, whether it's up or whether it's down. So line protocol. And then we attach that to the VRRP group. So in this case, VRRP group 1, track 1, links us back to this tracking object, and then we say decrement the priority. So we're decrementing the priority of this master router if this interface goes down. And so decrement it by 20, 110 minus 20 equals 90. Therefore, when the hello packet comes around, this router over here, that's currently the backup router, sees the hello with a priority of 90. So since its priority is higher and preemption is on by default, it will take over as the virtual router master. Let's configure object tracking for group 10. Now, why do we want to configure object tracking for group 10? Well, we need to keep an eye on the interface between DSW1 and R1. If it fails, traffic will not be routed out of VLAN 10 to the rest of the network. Now, why is that? Because DSW1 will still be the virtual router master, because the hello packets are still successfully traversing through our layer 2 network, because there's no failure of the layer 2 network and there's no failure of DSW1 itself. It's the link. So if we type in configure terminal interface gigabit Ethernet 1/0/10 and we type in shutdown, notice there is no indication at all of VRRP state changes at all. So we're still the master. DSW2 is still backup. We do not have the ability with VRRP to directly track an interface like you can with HSRP. But through a tracking object, you can track an interface. So indirectly, you can technically track an interface with VRRP by using that tracking object. So let's do that. Let's create a tracking object. we're going to call it tracking object 1, and we're going to track an interface. This interface is going to be gigabit Ethernet 1/0/10. And what do we want to track about this interface? Simply its state. Is it up or is it down? If it's up, everything's good. We will remain the virtual router master. But if it goes down, then we have the ability to decrement the priority of DSW1 so DSW2 can take over. So what do we want to do in this case? Well, we want to check the line protocol. That's what we want to check. Changing up to down or down to up. So the tracking object has been created, show track. And we can see from the output of show track that the line protocol is up. And now how do we apply this to VRRP? We'll go to interface configuration mode for VLAN 10. We'll type in VRRP group 10 and track. Notice that you can't directly track an interface. You can only track the object. So the object we did was track 1, and we want to decrement the priority to a value that will be less than DSW2. So right now, DSW1's priority is 255. DSW2 has a priority of 100. So 255 minus 100 is how much? 155. So as long as we specify a value, a decrement value greater than 155, that's right, greater than 155, then DSW1's priority will go low enough. So let's just put 200 there for fun. Now let's go to interface gigabit 1/0/10, and let's shut it down, and we'll see here that we become the backup now because the tracking object goes down. So since the tracking object went down, our priority went from 255 down to 55 because we subtract 200 from it, and we become the backup. Why? Because DSW2 promoted itself to the master. So this ensures now that if an uplink fails, we can have a successful failover of the virtual router master, and a backup can take over.